What if one line of code could add superpowers to any function without touching the function itself? That is what a decorator does. I am Mahaz. Today in episode 17, Decorators, you will learn the pattern behind Django, Flask, and FastAPI. You will build your own decorators from scratch. Timer decorators, validation decorators, retry decorators. And you will finally understand what the @ symbol actually does. Let's go. A decorator is a function that takes a function and returns a new, upgraded function. Without the @ symbol, you would write, greet equals my decorator of greet. That is verbose. The @ symbol is pure shorthand. You write my decorator on the line above def. Python does the wrapping for you, automatically. Look at the two code cards. Left, manual wrapping, ugly, error-prone. Right, @ decorator, one line, clean, readable. Same result, 0 extra code. This is why every professional Python codebase uses decorators everywhere. Every decorator has exactly 3 layers. Layer 1, the outer function. It receives the original function as an argument. This is what its syntax calls. Layer 2, the wrapper function inside. This is the new function that will replace the original. It runs your extra code before and after. Layer 3, the original function call inside the wrapper. The wrapper calls func of args and stores the result. Finally, the outer function returns the wrapper, not the result, the wrapper itself. This is the tricky part most beginners miss. You return the wrapper object. Python stores it as the new version of the function. Let's build our first real decorator, @timer. It measures exactly how long any function takes to run. The outer function is called timer and receives func. Inside, we define wrapper with *args and *quargs, so it accepts any arguments. We call time.time before and after func runs. We print the function name and the elapsed time. Then we return the result. Now we write @timer above any function we want to measure. Call slow function. Python automatically prints slow_function : 2.0031 seconds. You can drop @timer on any function in your entire codebase, with 0 changes to the function itself. That is the power of decorators. What if you want a repeat of 3, a decorator with an argument? You need 1 extra layer of nesting. The outermost function takes the argument in. It returns a decorator function. That decorator function takes func. It returns the wrapper. 3 layers instead of 2. This is called a decorator factory. When Python sees a repeat of 3, it first calls repeat of 3, which returns a decorator. Then it applies that decorator to the function. Watch line 11. At repeat of 3 above def say hi. Calling say hi now prints hi ! 3 times. No loop in the main code. The decorator handles it. You can stack multiple decorators on one function. Write @cache, @logger, @timer above def greet. Python applies them bottom to top. So greet is first wrapped by timer. Then that result is wrapped by logger. Then that result is wrapped by cache. Calling greet now runs all 3 wrappers. Watch the layers stack on screen like a sandwich. Each layer adds behavior without modifying the one below it. This is the open-closed principle. Open for extension, closed for modification. It is one of the most important principles in software design. Here is the mistake 90% of beginners make. Without functools.wraps, your decorated function loses its identity. Call print of greet.donnerName, and you get wrapper, not greet, wrapper. That breaks documentation. It breaks debugging. It breaks any tool that inspects function names. The fix is 1 line. Inside your decorator, above the wrapper def, write @wraps of func. Now greet.name returns greet. Greet.doc returns the original doc string. Everything is preserved. Make this a habit. Every decorator you ever write, add @wraps of func. It costs 1 import and 1 line. It saves hours of debugging. Python ships with 3 built-in decorators you will use every single day. @property turns a method into an attribute. You write c.area with no parentheses. Python calls the method for you. Perfect for computed values. @static method removes self entirely. Use it for utility functions that belong to the class but do not need instance data. A class method receives CLS, the class itself, instead of self. Use it to create alternative constructors. Here, from underscore diameter takes a diameter, divides by 2, and returns a circle. These three decorators are the backbone of professional Python classes. You will see them everywhere, in the standard library, in Django, in everything. Our mini project, at validate_types. This decorator automatically checks every argument's type at runtime. You write at validate types with name equals string and age equals int. Now if you call create user with name equals 123, Python raises type error, bad type, name. You did not write a single if statement inside create user. The decorator handles all validation. This is the pattern FastAPI uses for all its route validation. This is what Agentic does under the hood. You have just built a simplified version of one of the most used patterns in modern Python web development. Your challenge: build at retry of n. Step 1. The decorator should retry a failing function up to n times. Step 2. Print the attempt number every time it retries. Step 3. If all n retries fail, raise the original exception. Step 4. Use at functools.wraps inside your decorator. Step 5. Test it with a function that randomly raises value error. This is a real production pattern. Requests to APIs fail. Database connections drop. At retry is how you make your code resilient. Paste your complete code in the comments. I check every single one. Let's recap what you learned today. A decorator is a function that wraps another function. The at symbol is shorthand for manual wrapping. Every decorator has an outer function, a wrapper, in the original call. Use *args and *quargs to pass any arguments through. Always use at functools.wraps, always. Stack multiple decorators. They apply bottom to top. The three built-in decorators are property, static method, and class method. We built at validate types, a runtime argument checker. Your challenge is at retry of n, a real production pattern. Next episode, async and await, the pattern behind every modern Python web server. Subscribe so you don't miss it. See you tomorrow. Decorators, mastered. You can now add superpowers to any function without touching it. Subscribe for the next episode. Drop your retried decorator in the comments. I am Mahaz. See you in episode 18.